Hello students, welcome to Vyas Certification Kota. In this series of NCERT discussion, it is time to continue further with Mathematics class 12th. The chapter that we are dealing with is application of derivatives, and yes, we will be dealing with exercise 6.4. Now, let's begin with the first question that we have over here. Question number 1 has a lot of parts, and this is the first part that we are beginning with. A particular type of question is being asked over here, and we'll be discussing the concept first of all. What is being asked is, using differentials, find the approximate value of each of the following up to 3 places of decimal. That's what we are dealing with. So let's begin with the idea that we are interested in. What is the idea? That if you have a function y equals f of x, the idea says that if you know the value of y at some particular point, let's say if you know this x and corresponding y at this location, if you know the coordinates of p, then for example, if you are asked to find the value of y for some slight distance greater than x. Slight distance, here I've taken a bigger margin, but if you are asked, let's say for a small increment in x, what's the increment in y? So actual increment will be something else. Let's say if this is delta x, this point becomes, if this distance is delta x, then this point is x plus delta x, and the value for x plus delta x will be actually something. But then instead of actually finding that value, what we do is we approximate the value with some idea. What's that idea? We draw the tangent over here at this point. Now, for this particular point, x and y will be known, and the equation of tangent will also be known. On the basis of that, we comment that instead of this value, which is generally difficult to find, as you can see over there, you can easily find this value. What is this value? This particular value. Okay, and what is this value over here? This increment. Can you please observe that this triangle is very easy, and you can observe, since theta is nothing but the slope of this, theta is the inclination of this line, and tan theta will be nothing but dy by dx. Oh, tan theta is dy by dx, yes. On the basis of this delta y is very easy to find. This is approximately delta y, and delta y will be equal to delta y upon delta x will be tan theta. This will be equal to delta x times tan theta. Oh, so what does that give me? That gives me that this particular value, the function f at x plus delta x, will be equal to what? This will be equal to this value that is f of x, the value of function at x plus something called delta y. And what is that delta y? Fx is okay, this is approximately equal to, delta y is further delta x times tan theta. And what is tan theta? Tan theta is nothing but dy by dx, and this is some result that you can remember. This is a result that you can remember. Yes, f of x plus delta x becomes equal to f of x plus something, and that something is delta x times dy by dx. The change in x times the derivative is what I get. That derivative is nothing but tan theta, right? Simple concept of trigonometry is used in this question over here. Right. Once you are clear with this idea, then in such questions where we want to approximate using differentials, the important thing is to identify the function first of all, and then the increment. That's the important thing, right? So if you observe, this is square root of 25.3. It is close to square root of 25. Now square root of 25 is clearly known to us. That's 5, right? So once that is clearly known to us, what we can easily do is, let us begin with f of x is equal to square root of x be a function. Let f of x equal to square root of x be a function, and if you are asked f of x plus delta x, which is f of 25.3 is being asked, f of 25.3, which will be under root of 25.3. Therefore, this will be equal to f of 25 first of all, f of x first of all, because square root of 25 is something that I know, I am aware of, right? Okay, so 25.3 is something which is asked, and 25 is something that I know of. This is actually the difference delta x. The difference of these two values is what you call delta x, right? This and something added in this. Can you please observe? X is 25, x plus delta x is 25.3. The difference of these two will be delta x, and that is something which is required over there, plus delta x. Delta x is 0.3 times the derivative dy by dx, which is actually f prime x. Do you observe that? This is f prime x. That's clear, right? So using this particular expression, using this particular result, I can find the approximate value of this. Mind you, this is approximate value. This is not exact value. This is approximate value, right? F of 25 is clearly known. 0.3 is clearly known. What's the derivative of x? At x equals 25. This is required, right? What's the derivative of x? Can we find the derivative of x easily? Yes, derivative is very, very simple over here. So this will tell me that square root of 25.3 will be equal to square root of 25 plus 0.3 times derivative of this is 1 upon 2 root x, right? So that becomes 1 upon 2 root x. What is x? X is 25, right? So this is 2 root to 25. That's what you get. So this is approximate equal to this with further equals to this is 5 plus 0.3 into 1 upon 2 times 5. What is that? 1 upon 10. So this becomes 5 plus 0.03. This is what you get, which is equal to 5.03. That is my answer for this question. Okay, up to 3 places of decimal. So we are getting only 2 places. Let's see. This is 5.03, and yes, using this idea, we have found the approximate value of square root of 25.3, as you can see behind me. That's a complete solution for this.